1.53 degrees over the last 50 years. How is it that the oceans, so very deep and cold, have warmed up? Is it the almost imperceptible rise in the temperature of the atmosphere? Why would this slight warming of the air affect the oceans? Oceans have 1,000 times more heat capacity than the atmosphere. This means oceans can heat the air far more than air can heat the oceans. The atmosphere would have to heat a lot before it could heat the oceans a little. What should be especially noted, most of the ocean heating occurs down deep, in deep ocean rifts. Oceanographers are baffled. Temperature measurements of deep oceans, over some last 20 years, find more heat than expected, more than surface and intermediate waters. The depths of the oceans are warming. Polar ice is melting rapidly at both North and South poles, but more over oceans, in the Arctic. 90% of Arctic ice is below the ocean surface, exposed to water. The warming ocean comes underneath the ice shelves and melts them from the bottom up, says glaciologist Jays Wally. Warmer water is rising from the depths to erode the ice from below. But melt is occurring in the depths of ice massifs over land as well, which especially alarms climatologists. In some cases, huge sections of ice are starting to thaw right in the middle of Antarctica ice sheet. Scientists have no explanation for this phenomenon so far. Permafrost layer in European part of Russia, Siberia, Alaska, and northwestern Canada has seen almost universal increase in mean annual temperature since the 1970s. Permafrost boundary has been shifting north at 20 to 30 kilometers per year. This is already starting to bring on infrastructure trouble in those regions where it has been built on permafrost. And, like the polar ice, it is also melting from below. The best explanation would be that the deep oceans are warmer due to heat coming from the Earth's core. Heat constantly migrates from the core of the Earth to the surface. This heat keeps lakes from freezing solid after ice forms on the surface. It keeps the ground from freezing more than 6 feet deep in the winter. It causes deep well water to be hot, which can sometimes be used for geothermal heating. The oceans are warmer because the core of the Earth has heated up. And it does so in response to its brother coming closer, the 12th planet. It is disturbing Earth's inner core, roiling it, and this heat translates into warming of Earth oceans, and melting polar ice from underneath. Geologists all over the world are observing signs of a very disturbed mantle and core of the Earth. The outer core and mantle are getting extremely heated. It is showing signs of molecular agitation. Mantle viscosity is going down due to increased temperature, which causes increasing earthquakes and volcanic activity. The volcanoes above sea level are the best known. But the vast majority of the world's volcanoes lie beneath the sea, sitting along the mid-ocean ridge systems, along the plate boundaries. Most of the Earth's volcanism, up to 80%, occurs at the ocean bottom, with eruptions proceeding unobserved, covered from the human eye by the ocean waters. An astounding total of close to 3.5 million submarine volcanoes is estimated to exist worldwide. The vast majority are located in the depths of the oceans. Ocean rifts are currently experiencing an unprecedented level of activity, going up by several folds in 2005. There are currently over 5,000 active underwater volcanoes. Underwater volcanoes are pumping red-hot lava, 2,200 degrees Fahrenheit hot, into the seas, and heating them. Superheated waters inside the vents can reach 750 degrees Fahrenheit, 400 degrees Celsius, hot enough to melt lead. The net result of this action is thermal heating of the oceans, at key points, in deep ocean trenches, which is carried aloft, eventually resulting in heating of the atmosphere. Climate is controlled by the oceans, not the other way around. As the oceans are heated, ocean currents become erratic and create odd disturbances in the atmosphere above. there is more water vapor released from the warmer oceans, contributing to more powerful, more energetic atmospheric processes. There is more turbulence in the air masses, disrupting atmospheric circulation. Winds of high velocity are created and driven over the land areas. The warmer seas pump more moisture into the air, which inevitably results in more precipitation. Today, the world is concerned about limiting industrial emissions. But this factor is not even 10% of CO2 emissions, as the result of geotectonic processes. Volcanoes put 2.3% as much CO2 into the air as humans every year. One volcano can put the amount of CO2 into the atmosphere that whole human industry produces in a decade. And volcanoes have been doing this for 5 billion years. The reason why CO2 levels in the atmosphere are increasing is because warmer oceans release more CO2. It is estimated that atmosphere contains 780 GTC, gigatons of carbon, while the surface ocean contains 1,000 GTC. And the intermediate and deep oceans contain 38,000 GTC. Oceans exchange 10 times as much CO2 with the atmosphere as humans produce, 90 GTC, and 19 times faster. Oceans regulate CO2 in the atmosphere. Undersea volcanoes are estimated to account for 75% of global annual magma and gases output. Gigantic gas emissions occur, which human emissions could not even be compared to. Increased activity of undersea volcanoes is raising CO2 concentrations in the oceans, leading to ocean acidification and algae blooms. Then, why didn't volcanoes acidify the oceans many times over, in the course of billions of years? Where does all this volcanic CO2 go? Oceans tie up extra CO2, as calcium carbonate, in coral reefs, gradually forming limestone sediment. And recent increased volcanic activity in deep ocean rifts only adds slightly to CO2 concentration, with heated oceans, then releasing this excess CO2 into the atmosphere. Rising CO2 levels are the result of warming, not the cause. Earth is not the only planet to be affected by the magnetic push of Planet X. Mars, Jupiter, Neptune, Pluto, and others share the fate of the Earth. Global warming on Mars is a well-known story. Between 1975 and 2000, Mars warmed up by 0.65 Celsius degrees, much faster than Earth. New findings from NASA's Mars Odyssey orbiter is giving indications of recent climate change on Mars. Dr. Jeffrey Plott, project scientist at NASA's Jet Propulsion Laboratory, Pasadena. Scientists who study Mars have concluded that the red planet has been actively changing recently. Big crevasses and cracks were noticed on sandy flanks, 3 years after they were photographed in 2002. In 2005, data from NASA's Mars Global Surveyor and Odyssey missions revealed that the area of carbon dioxide ice caps, the glaciers that consist of frozen carbon dioxide gas, near Mars's south pole, had been diminishing for 3 Martian summers in a row. Scientists suggest that such an intensive evaporation can be setting off stronger winds on the surface, which are changing Mars's relief. There is evidence of past pole shifts on Mars, found by scientists. The degree of the shift is lesser than the Earth experiences, because there is less fluidity in Mars's core, which has cooled and solidified. Damn those little green Martians. They must be working in their little coal plants, releasing greenhouse gases from their combustion engines, and cutting down all the, moss. Oh, what the fuck? Them little green bastards are even on Jupiter now too. A new storm, and a new red spot on Jupiter, hints at climate change. Global temperature change of about 10 Kelvin degrees destabilizes the atmosphere and leads to the formation of new vortices. In 2005, photographic evidence showed that Jupiter has developed a tilt to its axis. Europa, one of Jupiter's moons, is noted to be heating up, too. And in May 2008, Europa actually had a pole shift. Its axis of rotation, ice-laden poles, shifted almost 90 degrees, and changed their places with the equator. The previous axis is now located about 10 degrees from the present equator. Wandering poles left scars on Europa. Europa adjusted to particle flows coming from the approaching planet X, as did other planets and moons in the solar system. Saturn itself has a rather warm south pole, and the temperatures in that region suddenly jump by 3.5 Kelvin degrees. In July 2004, Cassini probe sent unexpected new data about Saturn. The rotational period appeared longer than that determined in 1981. As of today, rotation period of the planet is approximately 6 minutes longer than 30 years ago. Scientists are sure about the precision of their measures, old ones, as well as newer ones. What's more, Saturn appears to have its tilt affected in the same manner as Jupiter, leaning its top. A moon of Saturn, Enceladus, was expected to be frozen and cold. Suddenly, Cassini has informed that Enceladus generates its own heat. Its high temperatures seem to be incompatible with calculations based on solar energy itself, according to existing models. And there is also evidence for polar wander on Enceladus. The climate of Neptune, more precisely its reflectivity, was recently changing, Lockwood and Hamill argue in Geophysical Research Letters, Volume 34, 2007. Global warming was detected on Triton, Neptune's largest moon. Between 1989 and 1998, the temperature jumped by 5% on the absolute Kelvin scale. The same relative increase would raise the Earth's temperature by 22 degrees Fahrenheit in 9 years. And it seems those little vermin even got to Pluto too. Pluto is undergoing global warming, as evidenced by the threefold increase in the planet's atmospheric pressure in 14 years, and the associated increase of temperature is estimated to be around 3.5 Fahrenheit degrees. That's a 300% increase, which is the highest increase in any planet in the solar system, and it is increasing as Pluto orbits away from the Sun. The Earth is experiencing warming, too, although less dramatic than the previous examples. Venus, this planet doesn't belong to the list of planets where recent warming has been demonstrated and which are known to be currently warming. The same case is with Mercury. Simultaneous warming on Earth, Mars, and other planets of the solar system suggests an outside cause. A known external factor must be affecting all these simultaneously. But even more astonishing is the fact that outer planets are affected more. We have Pluto warming up to 4 times. Giant planets and their moons, to a lesser degree. Mars ice caps shrinking, and planet's surface radically reshapen. With Earth warming only 0.6 degree. And Venus and Mercury, those planets closest to the Sun, barely affected at all. This proves that the cause of this is not the Sun, another favorite explanation. Global warming excuse has fallen out of favor recently, to be replaced by its alternative, blaming the Sun. Some science is starting to emerge lately, trying to demonstrate correlation between solar activity and Earth events, like earthquakes, volcanoes, hurricanes, floods, and storms. A statement that Sun is affecting the core of the Earth is ridiculous. Solar flares? These may affect radio transmissions and cause electromagnetic interference, but do not roil the magma deep under the crust. For the core to be heated by solar flares, the surface would have to be way warmer than the core, which clearly is not the case. There is no relationship of sunspot activity to earthquakes. You can always find an example of a sunspot being present ahead of an earthquake.